So you may have noticed that the title of this video references something called PixelGen. Now PixelGen is not the name of the game I've been working on and I'm developing currently, but is the name of a piece of software that I've been working on for these past couple weeks. Basically, it's a pixel art generation or automation software. I've talked a little bit about this in the past, but for the past couple weeks I've actually started to implement it, and I'm really liking the direction of where it's going, how it's going to help me in my workflow, and how it may help many of you in your workflows in the future. So without wasting any time, let's just jump in and see what it is and how it works. Creating pixel art animations is a time-consuming process. There's really no two ways around that. Even with all the copying and pasting in the world, it can still take hours to create simply only one character with a few animations. And the more frames you add to the animations and the more characters you add to your game, the price on time grows exponentially. That's what I'm trying to solve with this invention of PixelGen. I want to distill this entire process down into simply creating just a handful of images, pressing generate, and getting all of the animations you need to create your game. This means that features in the game and characters in the game don't have to be thrown out due to time constraints, but can be included on the day they're thought up without hours and hours of overhead. So how does PixelGen work? Before I jump into it, I want to give you a warning that this may get a little confusing. It's easy for the computer to understand, but it can be a little overwhelming for us to understand. So now that you've been warned, let me jump into it. It all starts out with three different images: the T-pose template, the animation template, and the T-pose. The T-pose is what you pass in, and these templates exist in the background. Now, when I'm talking about T-pose, I basically just mean a base generic position for the character that shows them off pretty well, without like legs crossed or arms folded or head moved back, just their generic position. This is in reference to 3D animation, where you start off with a character in the position of a T-pose, just so that you can easily add bone structures to it and manipulate its movements as you need to. That's simply the reference, but it basically means a generic character's position. So we start off with these three images, we pass them together with a bit of middle magic, and we ultimately come out with this final image. Now that may sound all great and all, but of course there's stuff going on in here, so let me jump into all of that. And before I explain exactly how all of this is working, let me explain how these templates are structured. It's a little garbled here, but basically for the T-pose template, the only requirement here is that every single pixel value is unique. To achieve that, what I've actually done is I've taken the templates and I've split them out into 3 layers. So instead of having this, I have this. That lets me reuse pixel colors without reusing them. You see, this color, or this color right here, is the same color as this color right here, and that's fine because I've split them out. This just lets me be able to use a smaller variation of colors so that I can actually understand what's going on and the computer can understand what's going on. But basically, the one rule is that the T-pose template needs unique colors for every single pixel. The animation template takes that information but doesn't have the same requirements. So if we come down here, you'll notice that the colors are being repeated here as the image is being stretched and pulled for the animation, but the one requirement here is that any pixel value, color value that exists within these animations has to be from one of the pixel values within the original T-pose template. The T-pose is where we're getting the color values, getting the references back to the unique colors, and this is where we are manipulating them as we need to. So unique colors over in the T-pose template, and colors that reference back to the T-pose template within the animation. And then finally, we've got our image that we feed in. There are no requirements here, other than it should match the basic shape, the actual shape of the T-pose template, but you could even get a little free with that. This is the input information, and the user can format it and draw whatever they want. So, how does all of this work? Alright, so this is where it can get a bit confusing, and I'll try to make it as clear as possible, but it may even confuse me and I may even have to backtrack a little bit. So first of all, the algorithm takes this animation template starting out. So let's say it's actually on to the third frame down here. So this would be frame number 3. And it's working on the arms right now. So this section of the animation. So let's say it comes to this value right here. What it's going to do is it's going to look at that color value, and then it's going to go back to the same frame in the original and look for that color value. So it's going to be looking for that little bit of pink somewhere within this frame. And it knows that it's only going to find one instance of that because that's how we've created our template. It's ultimately going to find that value here, and we're going to record the XY position of that value. It's found that it's a matching color, so it knows this is the pixel we're looking for, and it wants ultimately the position of that pixel. Then it's going to come all the way over to the image we fed in, and it's going to look for that XY position, which would be right here. Now that it's found that actual color, it knows that this is the color we want to write back to the new animation that we're creating. So it's going to color this pixel this color. It does this for every single pixel within this entire animation template, writing all of this information, of course, not to the template itself, but to a brand new image. And what it ultimately does with all of this is it merges all of these different layers together so that we don't have a bunch of broken body parts into this final rendition. It's basically a whole lot of loops. It sounds complicated again, but it's really not that complicated when it's coding. I thought this was going to take me a month to puzzle out all of this, and I got the basic functionality working within a week, ultimately just figuring out the final bits in the second week. So that's how it works. And I will say that when you put all of these pieces together, press play, and see what happens, what you ultimately get is a very happy Chris. Everything's good there. That is a bit promising. It worked! Whoa, no way. I mean, needless to say, I find this very exciting. I mean, look at this. This animation, all of this, is completely generated by the computer. All I did was draw out this picture right here, feed it in to those templates, into the algorithm, and I get a walking animation in the matter of milliseconds instead of hours. Oh, this is just going to save me so much time, and I'm really excited about implementing the rest of this and actually integrating it into my process for game development. Before I end the video, I want to make something very clear. I think something like PixelGen, an automatic sprite generation tool, should exist within the vast majority of pixel art project workflows. If you know of something like this, please leave a comment down below with its name. But if something like this doesn't exist and you want to be able to use this tool in the future, please leave a comment with that request below this video so that I know people want this. And make sure to share the video with other game developers that you know so the word can get out. If I get a lot of positive feedback for PixelGen, I'm going to put it as high priority in my schedule and try to get an early version out so that people can play with it and work it into their video game design, because I really think that this can be a big success for pixel art video game developers like myself and like some of you. Either way, thank you very much for watching. Leave it a like if you liked the video, and I will see you in the next one. Ah. Okay. No.